Welcome back. This is episode 61 in our Let's Play series for Space Engineers Survival. I've done some work on the Autopilot script, um, made it display status information and rearranged it so that it's kind of in its final form, at least what's done so far. Put in some commands rather than it just being on or off. Um, so the programming block is on right now, but I am able to move around. But then when I issue 300 ticks, so that's why it's not perfectly up to date. But you'll see it, then it says it's complete. So we'll do it because we put in a GPS string the first time, it saves it, and then you can refer to it by its name. Getting them back out is not possible at this point. Getting a list of them is not possible at this point. That's all to come. Um, so this stuff was here already. This stuff is all new. This is our autopilot mission and our autopilot status. The mission is what displays here. The default, if there's nothing in storage, is disabled. But when we recompile or reload or whatever, it'll preserve the autopilot mission and load that from the storage. Autopilot status is something that gets refreshed every time it runs through the autopilot script, and that was what was showing the yaw and pitch offsets down here. This is our autopilot controller. It's the remote control. These are the autopilot displays. Right now there's just this one. These are camera blocks, which we're going to eventually use for obstacle detection. That doesn't work now because I haven't done any of that yet. Gyros, this is this, and the displays obviously are really the only parts that's functional. This is for the thrusters. It's based on which direction, so it can figure out the direction once and then just use it. I mean, it's not going to do it just once. It's going to do it every 100 ticks, but we're going to update our autopilot maneuver every tick when it's engaged. But we only need to check the ship to see if anything's changed as far as new gyros, new thrusters, whatever. Every 100 ticks, that'll be good enough. So that's for the thrusters. This is for our waypoints. The string's kind of redundant a little bit, but it's definitely easier to just look them up by the name rather than needing to search through the waypoints and get the name out that way. So that's the way that we're doing it, just with the dictionary, string to waypoints. And then this is an autopilot ready. This is false until it runs through the update autopilot script the first time and populates, the controller and the gyros at least, and the displays and all that stuff. It's actually just the controller and the gyros that it's looking for, because it's possible for the autopilot to do something without thrusters. When we have those commands that actually rely on the thrusters, obviously we'll want to check and make sure that those are populated, and we'll throw an error if that's not the case. So the update frequency is back to 100 by default when we issue an autopilot command and the mission is anything other than disabled or complete. It'll be we'll add in the update 1 here, so it'll run every tick, and then every 100 ticks it'll do the 100 tick stuff as well. So this is still the prefix stuff. That hasn't changed. Here's where we're loading stuff from storage. This is not actually being used anymore. This is the GPS marker here, but it's still there. It's just not being used. But anyway, this loading from storage, we do the INI stuff so that it can stay organized and whatnot. Try parsing it. If it doesn't work, then, whatever. It won't load any of this stuff. Obviously, it'll start from scratch. If we have a section, we'd want to do the waypoints first, by the way, because if we were in the middle of an orient, for example, and it tries to orient to a waypoint, the waypoints have to be configured, so we do the waypoints first. We have a list of waypoint keys, which is all the strings. We get the keys for each key in the waypoint data, create a dummy waypoint to store stuff in because we can't store it directly into a dictionary. I tried it. That's a thing. It throws an error. We parse the save data, pulling the key, translate it to a string, save it to that temporary spot there, and then save to waypoints to string split on the slash, because remember it's going to be section slash key name, and we just want the key name. I forgot that as well and had a couple of issues with that. So that's just doing that, and it sets it equal to the temporary waypoint that we have, and then it loops through and does that with all of them that are in storage. Then this is loading the autopilot mission. We may have other things to put in here eventually, but right now it's just the mission. So we look and see if there's an autopilot section, look and see if there's an autopilot mission key. Then we get the mission out as a string, default to disabled if it's not there. Update autopilot, because we want to make sure that if this is, if we do have autopilot set up here, we want to have everything configured before we process arguments. Process arguments is kind of our default thing. The way that this is set up, you can send a command and that will basically change the autopilot mission. So you can just say autopilot mission, just recently sent the command. Add prefix, we've seen already. Find prefix, we've seen already. Is connected, we've seen already. Save is just the opposite of what we did here. Set the autopilot mission. And then for each waypoint in the waypoints dictionary, set the section waypoints, the key, the value to string, and then save it all out. Here we've got the main method, update 100. We're updating autopilot, which is, like I said, setting all of those things. That happens the first time, but we want to make sure it stays fresh. So if we add any parts, bolt them onto the ship or whatever while the programming block is running, we don't have to recompile and rerun it. So that'll just happen every 100 ticks. Even longer would probably be fine, but there's no longer update type to this than update 100, so I'd have to keep a counter, and it's just not worth it. So now this is update 1. Usually the update 1 flag will not be set. However, if the autopilot is engaged, it will be set. So we clear the status because that gets set in the process arguments, and then we just call process arguments again, just like we did up here. So when we send a command to start things off, we process arguments. When we're updating, we process arguments. If update source is done, it's because we passed in an argument, so we're just going to take in the argument from here. And that might be an autopilot command, it might be something else. In this case, on this ship right now, it's just an autopilot command. So this is update autopilot. This is where we're setting everything up. First, we're going to get our remotes. We're looking for something that has, or a remote control block that has custom data of autopilot controller in it. If we don't find one, if the count doesn't equal 1, or if we find more than 1, it's it's going to confuse it. So if the count is not 1, it's going to say update autopilot failed. So many configured remotes found, which is either too many or not enough. So we're only going to have one autopilot controller, and it has to be a remote control block. We could realistically just set this to iMyShip controller and use a cockpit as well, but I think it's better to have it as a remote control block, just to keep things from getting confused down the line. I might find a legitimate reason why I want that to be the case, but for now it just feels safer. Then get the gyros. We want everything that's attached to the ship. There's no reason not to use gyros here. Like if there's a gyro that we can use, we might as well use it. There's an argument to be made for, having gyros that, or at least one gyro that is not configured so that we can roll, like while we're orienting, because everything's, the gyroscopes are in override mode, so we can't roll while they're locked on. But I don't think we need that for the time being. We will eventually want them to control the roll as well, so having spare gyros that are able to mess with that is probably not a good plan. If there's no gyros, then that's an error. We're really just echoing these errors out for now. We may want to do something a little bit more interesting, put it out on the status screen, but for now we're just echoing it. And they'll stay there because every time it runs, it's going to say, hey, there's no gyros here, so we'll either have to configure a remote and it'll catch it, or add gyros and it'll catch those. Here's where we're looking for screens. We're not actually pulling the thrusters, we're not pulling the cameras right now because there's no use for them right now. So I haven't coded that up to even look for them. But this is just all about the screens. So we're going to grab all the terminal blocks because there are various kinds of terminal blocks that could have screens. The cockpit has screens, the programming block has screens, LCD panels obviously have screens, but anything that has a screen, first of all, it needs to be connected. It needs to be part of this grid. Second of all, it needs to be a myText surface provider. So if the block is not a myText surface provider, return false, bail out. And this is basically an if you can cast it, because I tried not doing this and just doing block as myText surface provider, and that blew up because it couldn't cast some of the blocks. Obviously O2H2 generator, for example, you do O2H2 generator as myText surface panel, it's going to give you nothing. And so trying to access anything on that's a object not or reference not set exception or whatever it's called. So test it first, and then if the surface count is 0, realistically, as long as we pass through this, we should be able to get through this. I'm pretty sure there's nothing that's considered a myText surface provider that doesn't have at least one surface that you can put stuff out to. But just in case, if the surface count is 0, return false. Then we want to check and make sure that the custom data contains LCD autopilot display equals. Now these need to be, one right after the other for the time being. There might be a better way to do this, and it might require actually just going ahead and doing the myINI stuff and looking for an LCD/autopilot display key. But for now, we're just looking for the text, playing without doing any processing. So if it's not there, bail. So next we're setting the surface ID to -1, just as an initialization, because if it'll get set to something that makes more sense, as we go through this loop. So at this point, now we need to go through each line in the custom data and find which one has a key of autopilot display. Again, all of this could be bundled up into a myINI process, and that really probably is the better way to do that, and I should rewrite that to do it that way. But for now, this is how it is. So after it goes through this loop, in this loop, it's going to say if it finds the autopilot display, it's going to parse the value that it has. So for the cockpit block here, we have autopilot display equals 0. So the 0 index surface that you can get is the one configured to be the autopilot display. So if the surface ID is greater than or equal to 0, because it started off as -1, so that means it found something and it set it to something else. Save out the surface as cast the block to a myText surface provider, and then get the surface that we found. Set the content type, add it to the list of autopilot displays, return true. If it didn't find it and this is still -1, then we'll return false. It's not what we're looking for. Now, some of these checks are a little bit redundant. There's really no way it's going to get all the way down here because it's got a surface count. It's got something set as autopilot display. So really this is just if you, I don't know, put A in there or something, like some random number that doesn't exist. That's where you'll run into this. Although you probably get an error here before you get that far, or here at least. But yeah, so this is probably never going to happen, but you need to convince the code that it's always going to return something, so that's what that's for. Now, autopilot ready is based on the gyros count being greater than 0, and the autopilot controller is a myro remote control. If it hasn't been set, it'll be null, and that won't pass, so the autopilot won't be ready. If the autopilot is not ready, the autopilot mission is not ready, and it'll come out here and say autopilot's not ready, obviously. If it is ready, if the mission was not ready, then it'll set it to ready. And then the next thing it'll do, it will display to the autopilot displays, autopilot : mission status, clear it first. So the status gets updated in the process arguments, or in the actual arguments, or in the actual commands themselves. Like orient ship's really the only one that does anything at this point. So that's how that gets updated, but this is only happening every 100 ticks, so it doesn't update as often as the autopilot itself does, but it saves us some processing and saves us searching through all the ship blocks, every tick, which is not necessary. So here's kind of the meat of it. I told you this is, happening both when we load up and every 100 ticks. This is basically how we continue doing, or every tick rather. This is how we continue doing what we started doing and how we start doing what we want to do. First of all, we parse it into a command line. Also, we want to make sure that the argument count is greater than 1, because if you just send autopilot, that's not a command. So if you just send, autopilot as the only argument, then you're going to end up here with invalid arguments. Then we want to say, okay, well, we've parsed it successfully. And actually, this may need to change. Oh, it's greater than or equal to 1. So we have at least one argument, because if we try to do command argument 0 and there's no arguments at all, this is gonna blow up because it's gonna be trying to 2-upper nothing. So there needs to be at least one argument because this is greater than or equal to 1, and this is the argument count. So it's, it's one index. So if you have one argument, it's going to be 1 to get argument 0. So this needs to be greater than or equal to 1. Otherwise, there's no arguments to process, and it's invalid arguments. Like somehow you got in here without having any actual arguments, and that's not supposed to happen. So if the first argument is autopilot, if the autopilot's not ready, then bail. Like if the autopilot hasn't been updated here, if we don't have enough parts or if it hasn't been run, then we don't want to do anything. Now, valid command, we're initializing to false, just so that we can catch it at the end rather than making my if-else condition stuff look nasty. This is just the personal coding style thing. People may prefer to do it differently, but this is how I like to do stuff. So now for the autopilot commands, if command argument count is less than 2, there's no autopilot, like there's no command that's just autopilot. That doesn't do anything. So that's where we say here, it's not going to do anything. So we need to have at least 2 arguments to actually get in here and start looking at, what we're trying to do. The main reason being that we're going to check argument index 1, which is the second argument, and try to 2-upper it. So if there is less than 2 arguments, then this is going to fail, and then this is going to throw an exception when we try to do stuff to an argument that doesn't exist. So if the command is orient the ship, pass the command in. It's a valid command, set that to true, and then this if condition down here will fail. If the argument is disabled or the argument is complete, then we turn off the update 1 so it doesn't run every tick anymore. It'll just run every 100 ticks or when you send a command in. So this slows things down a little bit so that we don't have to worry about it overdoing it. This is basically how we stop the autopilot, disabled or complete. Because right now we're only doing orient, but the next command I'm going to do is lock, which is basically going to be orient, but then it's not going to turn itself off. It's gonna stay locked, so you'll have to send it to disable if you want to return control to the cockpit. For now though, once you're done orienting, it sets the mission to complete, which will turn this off. So if it's not a valid command, it's an invalid autopilot mission, and it tells you, what mission you tried to give it. It gives you the arguments, skipping the word autopilot, because it's substring starting at the autopilot length, which will be the end of the word autopilot. So if you send it in nothing, it's going to say invalid autopilot mission nothing. If you send it, autopilot monkey, it's going to say invalid autopilot mission monkey, because obviously monkey isn't an autopilot mission. That wouldn't make any sense. So that's how that works. Now, process argument for orient calls this orient ship method, which is right here. Passes in the command line as it's been parsed so that we can work with it. We're initializing GPS to missing GPS target. It gets changed here. If the command argument count equals 3, GPS equals argument 2, which is the third argument. So if this is not here, if there's only 2 arguments, or if there's too many arguments for orient, because the orient's only going to take 1 argument. So if argument count is 2 or 1, or 1 wouldn't get in here. If it's 2 or 4 or whatever, more than that, it's not going to change this, and it's just going to say missing GPS target. Then it sets this, initializes this reference without actually, it declares this reference rather, that's the word for it, declaring, then initializing. So here we're going to say if the waypoints dictionary that we have contains this, whatever this is, so this might be, SIC instead of a full GPS thing. So if the waypoints already has the name, then just set the target that we declared here to that waypoint by pulling it out of the dictionary. If it's not in the dictionary, then we're going to try to parse this as a GPS string and save it to the target as a my waypoint info. And then if that is successful, if we are successfully able to try parse, this will return true, and we'll add it to the dictionary under the name. So target is the my waypoint info. The target name is going to be a string that we can then refer to pull it back out here. So if you send autopilot orient a big long GPS string with the name SIC, it'll save it to waypoints SIC, and then moving forward, it'll say, first of all, down here, the mission will just be orient SIC instead of orient big long GPS string, because that would look nasty. It would run off the side of the screen. You wouldn't be able to read it. It wouldn't be particularly helpful anyway. So we're saving these by name so that we can refer to them by name. And then when we restart a mission, when we reload the game or restart the programming block or whatever, it'll be able to restart it without needing to know the full GPS string. It can just pull the waypoint out of the dictionary after it gets loaded from storage. Now, if we're not able to parse a GPS string, if we're not able to find whatever string we passed in the dictionary, then it's an invalid GPS target. If it didn't get reset because the argument count was wrong, it's just going to say missing GPS target. If it's not in the dictionary, it'll tell you which target you were trying to find that wasn't in the dictionary. If you passed in a bogus GPS string, it'll show you the GPS string that you passed in that didn't parse correctly. So that's how that works. Now here, we are setting our update frequency to include update 1. So the way that this update frequency works is it's a bitwise mask, which I've mentioned previously but never really explained, and I'm going to try not to go into too much detail on that here. If you're familiar with it, great. If you're not, Google it. It's not super duper important. But basically what we're doing is we're doing OR equals. So whatever's there already will be preserved, and it will also add in the update 1 bit. So it will run whenever it was running before. Right now it's running, on 100 ticks. And now it will also run on 1 tick. You could also set once. You could set, well, none wouldn't do anything. You can set 10 ticks. There are different update frequencies, but when you do the OR mask, it adds them together. And you've seen that sort of in the main method up here, where we do the AND equals, and then this is flipping it. So this is everything but this. So everything that was there already will stay there, but it will turn this one off. And it's not actually turning it off because we're not changing the runtime update frequency. We're just clearing it out of the update source here, so it doesn't count it again. Coming back to where we're setting it to run every tick as well as what it was doing before. So this will run every 100 ticks anyway, but now it will run every 1 tick as well. And when it runs on that 100th tick, it'll have both of these bits set, the update 1 and the update 100. So it'll end up doing the update autopilot and the process arguments. Lost where I was. Okay, so then we're setting our autopilot mission to orient target name. Because when we passed it in here, we had that, but we may have changed the target, the GPS from a full GPS string to just a waypoint label. So we wanted to use the waypoint label rather than the full string, because autopilot mission is what gets displayed on the LCD here. Now this part is exactly the same as it used to be from before, using the same method with the law of cosine stuff from the last episode, except now we're using target chords instead of SIC GPS chords, which was the one GPS my waypoint info we set up here. We're not using that one anymore. We're using whatever target we passed in. And we're using the autopilot controller, which may or may not be the remote that we were using before. Still out pitch, still out yaw, so that we can set both of those when the method returns. Now here we're changing the autopilot status, and this is something that gets appended after the mission when it's running. Autopilot mission, and then the status comes down here. We're just saying what the current yaw offset is and the current pitch offset, so this is how far we need to turn to get lined up. And this is only displaying while this mission is running, then it gets cleared. Now here, I did have a fairly complicated if statement. Well, it wasn't that complicated. It was, checking the absolute value and then flipping the sign appropriately or whatever. There's actually a math helper function for that called clamp. So this is much easier to use. Just clamp the pitch to negative attitude max and max from attitude, or positive attitude max. So this will make sure that this pitch, if it's less than this one or more than this one, it'll set it equal to this one or this one. It basically does everything that I was doing in that if statement, all in one function call that's already there. Same thing with the yaw. Now for each gyro in our gyros list, which we set up in update autopilot, we're going to run override gyro. Now this is override gyro basically does what the main method did before. It's right here. Gyro override set to true. If the rotation vector, and here I did put this into a vector. This is not, it's labeled as a vector, but really it's just three numbers being passed in as one object. So don't think too much about this as a vector because you can't really, this isn't something that has direction and magnitude in reality. This is just three numbers and it can be represented that way. So don't worry about that too much. Except this transform vector thing, that's new. That's how we deal with the orientation of the gyro. And whether this is a vector or not, it works. And I stole this code from Whiplash, I think is the name. He has I'm assuming genders again, so I apologize. Whiplash has a missile script, a guided missile script, and it's gotten fairly advanced as I understand it. But I found a paste bin of the source code through Reddit, and I will post the link to the source code in the description here so that you can check it out yourself and see what his version is. It's basically the same, except he's looping through the gyros in this method rather than outside of this method so that he only has to do something once, but I'm not doing it that way just because there's really... His way is probably better because it involves less math being done each time, but this is fine. Anyway, so we're transforming the vector. Before I do that, override gyro is pretty much the same here, pretty much the same here, pretty much the same here. The one difference is that if we have reached our desired orientation, we change the autopilot mission to complete, so it will no longer try to do anything. Now, transform vector. We pass in a vector, which is the pitch, yaw, and zero. This order, again, it kind of makes some intuitive sense. You're pitching around the x-axis, you're yawing around the y-axis, and you roll around the z-axis. So this does kind of make sense, this order. And again, the main thing is that it works. I don't fully understand how it works. I will admit that I am reposting and making videos about code that I don't fully understand because I'm not trying to get too deep into matrices and transposing them and whatnot. You'll see how nasty this code looks. It's not super nasty. It doesn't look that bad, but it's kind of opaque. It doesn't really make clear what it's doing. Anyway, we're creating a vector with the pitch, yaw, and zero for roll because we don't need to worry about roll here. We may need to worry about it at a later point, but not for now. Passing in the autopilot controller, which is our origin, and gyro, which is obviously the gyro that we're looking to override. So, transform vector. Again, I don't completely understand how this is working. I can kind of explain it a little bit, but this origin matrix is basically a matrix, and I don't understand matrices, so don't ask me to explain those. You know, that's what Google's for. Maybe you can follow it better than I could. But this matrix effectively tells you what the orientation of the origin is relative to the world. And you'll remember we passed in the autopilot controller, which is our remote control block, which is facing forward, right side up and everything. And then query, which is the block that we're trying to transform it to align with. We get the world matrix for that. So we want to see how the ship is aligned and how the gyro is aligned, basically. Now, first we're going to transform normal, and again, I don't fully understand what this function is doing, but this is what was in Whiplash's code, and it works, so I'm cool with it. What I can tell you is that what this is basically doing is it's taking our rotation angles here and transforming them so that they're not relative to the origin anymore, they're relative to the world. So that's why it's called absolute rotation. So first we transform the rotation so that it's relative to the world rather than the ship, and then we transform it again so it's relative to the gyro rather than the world. And again, I don't know why that works. I think that might be why the matrix transposes there here in this one. Maybe not, but anyway, the main thing you need to remember is that this is going from ship to the world, this is going from world to the gyro, and then we return a new vector that is the same length, the same values, but pointed in a different direction. So it's appropriate to how the gyro is oriented so that when we do override it here, these are always going to be the right directions, no matter which gyros we're using, which direction they're facing, whatever. I could attach, 12 gyros on here, each facing a different direction, and they would all be working in concert to rotate our ship to the proper alignment. Get direction to vector is basically the same. I did change this one right here. This used to be up, now it's down. When it was up, I needed to reverse pitch. And rather than do that, which makes no sense, just using down instead, it just looks a little bit cleaner. Otherwise, this is the same method, no changes there. And I added in the display method that we always use to display the same text to possibly multiple text surfaces. So yeah, that's everything. Like I said, the next step is going to be setting up lock. And lock is basically going to be exactly the same as orient. I may even put it in the same thing here, except instead of, letting it get away with setting the mission to complete when it's done, immediately after I'll change it back to lock to whatever point so that that's preserved. And then I will never end up coming into here. I will never end up turning off the one tick update, so it'll continue to update every tick and keep us locked on to whatever orientation we are trying to reach. In fact, that's so simple, I will go ahead and do it so that you can watch me write at least some code instead of just doing code review here. Command argument 1 to upper equals lock. You know what? Even better than that, I'm just going to send this in as a parameter, because otherwise I'd have to figure out what the target is again, and I don't want to have to do that. So this will evaluate to either true or false. If it is false, it's because we passed in orient. Like the only way it can get in here is if it's orient or lock. So if it's lock, it will be true. I need to make this all caps because I did the 2 upper. So if it's lock, this will be true. If it's orient, this will be false. Now we need to set up the parameter here. And then now it needs to come all the way down here. So I need to pass it in here as well. I didn't really count on that. I forgot about that. But yeah, I'm going to go ahead and do that because I think that that's still better. So those are the arguments to transform vector. That is the arguments to override gyro. Now, only if lock is true, or if lock is false rather, are we going to set this to complete. So if not lock, autopilot mission equals complete. If lock is true, it's not going to set it to complete. It's not going to reset the update frequency. It's going to continue to come in here and keep us locked on target. It will not actually do anything unless we've, started to try to move it. But because the attitude tolerance will all be within range. So it won't actually do anything. It'll just turn the gyro override on and then turn the gyro override back off. But it will continue to keep us locked on that point. Now, if lock is set to false because we called orient instead of lock, then it will go ahead and set the autopilot mission to complete. The next time it comes in here on the very next tick, it will get all the way down here and it will turn off the update frequency, and that will be the end of it. It won't, come back in here and re-override the gyros. I didn't write enough code to screw that up. Come on now. Apparently I did. Other equals lock. What is the problem here? 152 identifier expected. That's what that is. How did I screw this up? Oh, you know what? I don't have to do this here, because I'm passing in all of command. I can do this here instead. Not that that'll necessarily be any better. .173 identifier expected. What are you talking about? That's the identifier. Do you not like the name? Apparently. Apparently it doesn't like the name lock. That's probably a reserved keyword. Comes from me not knowing C#. So yeah, that worked. So now, if I turn us this way, and I have the control, the hotbar set up to do orient, so I'm going to just do this manually here. If I change this from orient to lock, run that, it still set the, oh, I know why. Because I actually set the mission inside orient ship right here. So instead of hard coding that, I will do command, I will interpolate it. Command argument 1 to upper. It did orient though. It did most of what it was supposed to do. So now I'll just run this again. Now it does actually say lock. It's pointing us in the right direction. And I can't turn it off more than, a little bit before it brings it right back. So now what I will have to do, I can go ahead and clear these because I don't think I need to see that anymore. These were just on here as indicators so I could see what was going on. I will set up 2 more commands. I will do this one to be Autopilot lock SIC. This isn't case sensitive because it does 2 upper. This is because this is the index into the dictionary for the waypoints. And then this one is going to be Autopilot disabled. So now if I run 5, it doesn't work. Oh, I think I know why. Because I come in here, I run the command, but I don't update the mission. So as soon as it comes in here again, it tries to run the same mission again. It never changes. So the fix to that is to set the autopilot mission equals command. I can't just set it to disabled because it might be coming in here for complete. There's not really any difference, but there's kind of a different implication. Complete means you finished the mission. Disabled means you stopped it. So now this should work. disabled. And now I can turn again. So orient goes to complete, and now I can turn. Lock orients and then stays there. Like it doesn't shut off until I actually shut it off with disabled. And now I can turn myself. So that works. So yeah, that's kind of the first level of functionality. The next thing we're going to need to work on here, and we'll do this in a little bit because I've done 2 coding episodes and I want to take a little break from that and maybe figure out if we can do some more building. That's probably going to mean, in this instance, going back to the uranium mine and expanding that a little bit. Possibly checking to see what other resources we're somewhat low on, and setting up a mine there. I think platinum is probably the one that we're lowest on, even though I don't know how much of that we really need. Maybe gold, because with gold we can start doing gravity generators and jump drives even. So yeah, I don't know if we need platinum for that or not. I don't remember. In any case, gold or platinum will probably be the mines that we work on next. But when we come back to this, when we come back to the autopilot, we will be working on controlling the thrusters so that we can say, orient to a point and fly there. And it'll, orient to that point. We'll want to make sure that we're clear of any obstacles because at this point in time, and this is something that we will have to add in the future, is obstacle detection. Like we can't, if I just told it to fly to space AU $, if I told it to fly to our gold deposit just then, it probably would have clipped the space industrial complex and wouldn't have been any the wiser for trying to do it. So we'll need to make sure that we're clear first, but then we'll be able to just engage the autopilot and it'll, fly off there. The trick is going to be stopping. It's going to be pretty easy, I think, to get us moving. That's just, orient and then turn on the thrust override, and then if our velocity is whatever cap we set it to, turn the thrust override off so that the engines aren't firing anymore, and then we'll just be on our way. And as long as the autopilot is engaged, we probably won't actually turn the thrust override off. We'll just set it to 0 because we don't want us to be, monkeying with the thrusters. We may even set this to disable so it's not controlling the thrusters, the cockpit, and I think the remote control block also. Yeah, have this option of control thrusters. So we'll turn that off and we will set the thrust override here. Can we set this to 0? No, that is set to 0. Okay, so yeah, there's no way to set it and hard code it to be off. We may even just turn the engines off. That's one way we could do it. Or the thrusters off. I keep calling them engines. But yeah, either way, when we're engaged in fly to mode, if we've got the fly mission, we won't want ourselves to be manually controlling that. We'll want to have to disable it first. And there may be some actual logic involved in that. Actually, I think there'd be some logic involved now. Yeah, see, because I hit orient and then I disabled immediately and we're stuck moving now. So there is a little bit more fanciness that needs to go into disabled. We need to stop overriding the gyros and stuff like that. We'll basically need to reset so that we can, return control to the cockpit even if we're in the middle of the mission. And that's not happening right now. So that's a fix that needs to be done for disabled, but I'll do that later as well. But yeah, so the idea is that we'll, start flying there, disable the thrusters so that or disable our control over the thrusters anyway, so that it maintains our heading. We might want to do some course corrections or enable us to do some course corrections because we do have an attitude tolerance in our orientation. So as we get closer, that little bit of offset, that little bit of tolerance will turn out to be, a much bigger error, that compounds basically as we get closer. And the further away something is, the more that error will matter. So like this will be more off than this one would be. So yeah, we'll have to do course corrections. But the main thing that's going to be a little bit tricky is, well, the course corrections will be a little bit tricky because we'll need to basically correct our velocity and we won't be starting from 0. And it's not really safe to assume that we're starting from 0 anyway. So like we could be moving, a lot faster than this. I mean, we've only got one ion thruster on the side of this, and we're still fully laden with uranium in the shuttle. So I mean, we're pretty slow in our acceleration here. But we could be moving fairly quickly in the wrong direction and, start up the autopilot, and we need to make sure that it, corrects our velocity so that we're heading straight for whatever point we're oriented towards. So that'll be a little bit of complexity, but the first step will just be, from a dead stop, like going from a dead stop and getting to the point where we are locked on an orientation and moving in that direction. And then we'll want to, the way we'll do the stopping is we will need to, I mentioned this a little bit last episode, we'll need to use the force equals mass times acceleration formula to basically take the mass of the shuttle, which we can get the amount of force available to us from our thrusters, which we can calculate, and figure out what our acceleration is, and then based on how far away we are from our target, decide when we need to start slowing down so that we don't overshoot it or crash into something, as the case may be. Especially until obstacle detection is put in there, crashing into something will be a risk, especially since a lot of these waypoints are involving pointing at an asteroid, which is where our ore deposits are. So that's how we'll do that, and then when we reach the distance that we need to start slowing down, we'll start slowing down, and hopefully that'll work. We'll build in some margin for error there, and allow ourselves to basically make course corrections where we'll say, okay, well at this point we want our speed to be lower to the point where it's eventually zero, hopefully when we're right on top of where we're trying to go. So that will be a factor, and that's how that'll work. So subscribe to see that eventually. But like I said, first we're going to take a little bit of a break from coding and do some other work around in the solar system here. Still mostly in this vicinity, like I said, collecting resources mostly, building mines to do that. So yeah, subscribe to see that. Likes, comments, and verbal abuse are welcome. Thanks so much for watching. See you next time. Bye.